afternoon everyone. This is Arpita and my topic for today's presentation is linear algebra. So linear algebra is the study of vector spaces and of the linear operations applying on them. Now in quantum mechanics, the quantum mechanics is based on solid graphs of linear algebra. Means we require a large amount of knowledge of elementary linear algebra to understand some of the notation and postulates of quantum mechanics. Now, some of the notations I am writing on the blackboard that are used in quantum mechanics are: first, we call this notation as cat xi. So, what is cat xi? Cat xi in quantum mechanics, we represent a physical state which have a particular spin orientation, and it is represented by a state vector, that is cat xi, in a complex vector space. This cat xi contain all the information about that particular vector space. So basically I can conclude that this cat xi is a vector notation of quantum mechanics in quantum mechanics. Now we have a bra equal to cat xi. This is a bra space. Basically a bra space is an bra equal to cat xi, means there is a one-to-one correspondence between cat and bra. Now the third topic we have is inner product. We call it bra phi and cat xi. This inner product gives us a value of a complex number in quantum mechanics. Now we have a tensor product of two cats which is represented by cat phi. Tensor product of cat psi. We also have a complex conjugate, transpose and Hermitian in quantum mechanics. So these are the notations of linear algebra that are used in quantum mechanics. So the basic object of linear algebra is vector space. Let us understand what vector space is. In mathematics, we had studied about vector space in our earlier classes. So vector space is basically an operation which is applied on a field which contains the scalar multiplication and additive property of an abelian group. Now let us understand what a field is. So field is basically a set of two binary operations that are abelian, that holds the abelian property of a group with addition and multiplication. So taking an example, let we have a space of, that is Cn, we call it that it is the space of n tuples of complex number, and it is represented by z1, z2 to zn. Linear algebra holds the additive property as well as the multiplicative property. So the additive property of linear algebra is, we can add two of the numbers from here. Here we have z1 to zn. This says that we take two pairs of vectors and it is giving us another vector which is z1 plus z1 dash till z2 zn dash. This is the matrix notation of a vector space.
Thank you, Arpita. I wish we had more time to listen to you. That was a fantastic presentation.